Hi, in this video, I'm going to make further review of this Metro X 3D scanner from Revopoint. Metro X has three projectors. One is the 7-line laser and the second one is the 14-line. It has two modes for the blue laser. The third one will be the structure light, will emit the lights in the blue color. Today, I will focus on blue laser testing. If you look at the Revopoint website, it has the scanning speed for the multi-line laser mode of 800k points per second. So it's a very fast blue laser 3D scanner. And if you compare it to the specification for the Latter Pro, it can only scan 660k points per second, which is slower than Metro X. So in this video, I'm going to benchmark the speed of the scanner. I'll start by checking the working distance on the 14-line cross laser, 25 cm. The marker that you see on the screen is spacing with the 6 cm, so I have no issue with the 6 cm. The first one was 6, now I increase it to 8. Alright, 8 is too wide, I think. Let's try with the 7-line parallel. No, 8 cm is too wide. I need to put it back to 6 cm. So let me measure the working distance for the 7 lines. It has the same working distance, which is very strange, 27 cm. 7 line is aimed for fine detail scanning, so it's supposed to be closer to the object. The camera is getting closer so it can scan high detail object, but the 7 line and 14 lines has the same working distance, which is very strange. I enable the GPU acceleration. I have an excellent testing score. Okay, I have arranged the scanning area and put the markers with a less than 6 cm spacing. Board size is 42 by 57 cm. Okay, let's take a look at this speed test chart. The Metro X in a cross line is slower than the 7 lines, which is very odd. Cross line has more lines and it's supposed to capture the surface faster than the 7 lines, but for the Metro X is the opposite. The parallel lines is 27% faster than the cross line. The cross line from the Metro X is 1. Slower than the 7 lines. 2. It gives a rougher surface than the 7 lines. 3. It used the same amount of the marker as the 7 lines. So, what is the point of the existence of the cross line in this 3D scanner? Even with the Raptor in 7 lines, the parallel lines, the original Raptor, which sell at similar price to the Metro X, is 116% faster than the Metro X, and for the Raptor Pro is 200% faster than the Metro X. Okay, so I'm doing a Metro X calibration. Start calibration. Accuracy check pass. Okay, next I'm going to test the precision of the scanner in 7 lines and 14 lines mode. By using this eggshell, I will scan in 3 orientation, 1, 2, and 3, and then I will merge them together and check for the seam line. Because the roundness of the eggshell is different, about 50 microns. Okay, I'll start with the parallel lines. Okay, the scan is still in parallel line 0.2 mm. Okay, this will be final orientation and parallel line 0.2. Start the scan. So I fuse all the 3 eggs scanned with a 0.2 mm resolution. Click on apply, isolated part, fuse point cloud 0.2, apply, merge. Okay, can I click more than 2? Preview the alignment. Let's generate the models. First scan we have 100,000 points. Second scan 130,000 points. Third scan we have 120,000 points. We should have at least 350,000 points, right? But you see here, after merging, the point cloud is only 157,000 points. When you merge it, I mean half of the point cloud is gone. Okay, I use a grid size 0.2, which is grid size for the point cloud when I originally fused it, 0.2 mm, and it's also the best resolution that this scanner can perform. Okay, let's click on apply. Okay, I still can see the seam line from the first and the second scan. And also can see the seam line from the third scan. Okay, let's export the mesh and compare it with the Raptor. Because of the variation of the eggshell is somewhere around 50 microns. So if you can't see the seam line after merging, that 3D scanner has a lower precision than 50 microns. When you scan the same item 3 times, you get a different dimension, so that's when it creates a seam line. Currently, there are only 3 3D scanners that I have tested in the consumer level that create no seam lines at all. MAF3, Raptor, and the Moose. The precision of the Metro X, the other is more than 50 microns, as you can see here. So this is not a metallurgy grade 3D scanner. Okay, next I'm going to test the accuracy of the 3D scanner with this aluminum block. The length from one side to the other is 149.95. So I scan with the 7 lines because it seems to perform the best. remove the marker. The radius is 3 and I click on apply. They cut out the hole with a 3 mm radius, but they not actually fill the hole. Let's export this as a point cloud. Going to drag this into cloud compare to this point. Okay, so we have 149.64, so it's smaller. It reads 149.646 or 304 microns, smaller than the actual value. So this is the lowest accuracy 3D scanner that have ever tested, and not only that it has lower precision, but it also has very low accuracy. So I do not recommend to use for reverse engineering, machining, or critical fitting parts. I'm tired. Okay, let's do this one more time, because the audience who sent me the Metro X, he said he really wants to know the drifting error value. So this time I adjust the test by adding more of the markers. I put more markers and make it wider. When it's wider, it has more leverage, so it won't be twisting when I drag. So this will be 2 meters. I use a LiDAR to recheck dimension again from this point to that point. Okay, let's check with the LiDAR. Okay, it reads 2.000. Okay, next I'm going to fuse it for 1 millimeter. Use a point cloud for checking the distance. Okay, here's the measuring result in cloud compare. I measure it from one point of the aluminum block to the other point. Okay, as you can see here, is delta X is reading 1997.854. It's 2.146 millimeter, too short. So that's a lot. In 1 meter, it will have a drifting error of 1000 microns. It say here volumetric accuracy is 0.1 millimeter per linear meter, but in my testing it's 1 millimeter per 1 linear meter, which is 10 times more than specification. The Revopoint always put a bus inside of the scanner for testing the scan, but I'm not going to scan this because it contains very low details comparing to the OWL, which has a very high intricate details on the feature. Let me fuse it. 0.2, 0.2, invert it. Oh, there's some noise here, so I will use isolation to detect it, and then I click on apply. Let me check this one. Isolation, detect, apply. Okay, so we have a first and a second scan ready for merging. I click on merge 1 and 2. Preview the alignment. See, the black eye is not scanned, see here, and also the nail of the owl is not scanned because it's black color. I space it to 0.2 millimeter. Okay, this is grid size 0.2. Okay, now let's try a lower than 0.2, let's say 0.1. So you get more faces. This is 0.1. From what I can see, you get more polygons, but you earn nothing from the resolution. See here, it's still the same. This one has twice the number of faces than this one, but it has the same detail, which is the lowest detail in my outscan testing chart, as low as the outer light. The eye is not scanned. We both know that when we fuse the point cloud because the eye is missing, and also the nail of the owls, which is in the black color. Some nail is not displayed here, and if you look at the detail of the feeder, it's much lower than the one from the raptor. See, the detail of the eyes is much lower, and if you look at the eggshell, it's the same like when we scan the egg. It gives a rough surface, and there is a seam line here, as you can see, because it has a lower precision. Okay, let's move to the back side. Detail of the feeder from the raptor is higher than the detail from the Metro X, and the smoothness of the eggshell is also different. Okay, and if you want to know the differences between the Metro X scan with the parallel lines and the cross line is on the left. From what I can see here, it's cross line and parallel line contain the same amount of the detail, but the cross line has a rougher surface, which will translate into a less of the accuracy and precision. So it's much rougher than the parallel line. So if I choose the parallel line for testing, that would be the best blue laser mode that Metro X can achieve from the scanner. Okay, I think it's the same for the detail, only that on the place where the surface is smooth, the cross line mode will produce more noise. The range number 16, it has some embossed text here. Revopoint has this mode. I use parallel line, right? A metallic surface mode, which is I will use to try out metallic shiny object, and I will set the resolution to so if I choose a metallic and shiny object, the resolution will be dropped to 0.3 millimeter. 0.3 is too wide. I mean, this object should be 0.2 millimeter. Okay, let's try with the metallic surface. But this will give Revopoint a lower detail when do a comparison. Automatic exposure. Okay, let's start scanning. Let's try a general, and I will drop the resolution to 0.2. You get the highest resolution. You can scan. Flip over and make another scan. Okay, let's process data. I'm gonna fuse it. 0.2. Click on apply. Okay, so next I'm going to go to the second one, doing the same thing, fusion, 0.2, just invert, delete, delete. Let's do isolation. Okay, let's merge them together. Okay, click on 1, 2, 2, 3, and 3. Generate model. 0.19. Auto hole filling. Let's export the model for comparison. Okay, let's take a look at the comparison side by side. I apply a metallic material, the same one. The Metro X has a rougher surface and the inside of the socket is not scanned. The text on the left is clean. On the Metro X has noise. Let me zoom in a bit here. Has some noise, and if I move it to the side, okay, you can see the side here has a rough surface, and the 16th number has a noise and rough surface inside of the wrench. As you can see, it's quite rough for the Metro X. Okay, let's move to the next object. Okay, next I'm going to make a 3D scan of this controller. I already applied the 6mm marker, parallel lines. Let's try if I can use black object mode. If you choose the black object mode, the preset point distance will be set to 0.3. Let's try global marker tracking. It's lost the track, so it doesn't work. The global marker doesn't work. Parallel lines, black objects, 0.3 minimum. Okay, let's start. .3. Okay, let's apply this. So the continuous scanning is not work. Everything that I have deleted will come back. So the best way to scan this is by do a separate scanning and merging. I need to mesh it before I can fill the hole. Let's try a hole filling auto. Grid size will be 0.3. Let's apply this. Okay, here's the result. I will export this for comparison. Surface from the adapter is sharper and smoother. If you look at the seam here, it's sharper than the one from the Metro X, obviously. And they both cannot scan the transparent button. The adapter has some defects from the marker that placed closer to the edge. And the Metro X has a defect from filling the holes, which is not smooth. See, this is automatic removal from the adapter, and this is hole filling from the Metro X. This part of the controller is very glossy. The Metro X doesn't do very well. And if you look at the Xbox letters, see, it's quite blurred and shallow for the Metro X, and it's sharper for the adapter. The Metro X has defects from filling the holes of the marker. And for user experience, it's a lot more difficult to get the scan, this scan from the Metro X. Continuous scanning doesn't work. It's not remove the deleted turntable. Come back when I do the rescanning, which is make me pretty difficult for scanning and removing. And the adapter is much easier to scan with. Okay, let's move to the final object, the car panel scanning. So I will use cross line, and the resolution I change it to 0.6 millimeter. Would be enough for this car panel. 0.6. Usually I will use 0.5, but Metro X is quite slow, so I will use 0.6. And the global marker is not working very well, so I will just start scanning, see if I can scan this car panel. Start the scan. Let's fill support cloud 0.6. Remove the marker. The marker that is 5. Okay, panel is filled. I'll click on mesh, hole filling, apply. Meshing is completed. Maybe I have to do this manually. Okay, click on this one, this one, this, and this, and this, and this, and also this one. Okay, every hole is filled. Small one here. Click on apply. Okay, hole filling is completed. On the right is a Metro X, and on the left is the Adapter Pro. So for the Metro X, it has a rougher edge. I mean, the edge is quite rough, and the major issue is that the software cannot fill the marker and smooth the hole. You probably need to use it like this, because if you smooth it, the dimension will change. Number one. Number two is that the car panel, you can scan only one side, so it's not fully solid, it's just a surface, not an enclosed solid. If you smooth it, it's going to create a lot of problem. The Metro X can scan the reflective logo and the matte black color of the screen wiper. The laptop Pro can scan it, but for the Metro X, it entirely disappear. Okay, if you look at the edge here, it's quite sharp and smooth. Okay, the surface is quite smooth. There is no post-processing. This is out of scanner Metro X. See, it's the striking line is quite severe, and the handles, it's quite it has striking lines. So what makes the good 3D scanner? For me, number one is the precision, the ability for the 3D scanner to capture the same object many times and give the same result. That's more important, and the firmware update or software cannot fix that. Number two is the accuracy. Accuracy is the comparison of the measurement from the scanner with other measuring tools like a vernier caliper. And number three is the resolution. But from this testing, the Metro X doesn't have any of that. It gives a low precision, low accuracy, and low resolution. Number four is the speed. It's the time that you spend on scanning one object. The blue laser from Metro X is very disappointing. It doesn't perform as it should be. It doesn't behave like a laser scanner at all. Thanks you guys for watching. I'll see you in the next video.